Hi everyone, in this video we are going to review the concept of structures in C programming language. We'll get to know how to create them, how to use them, and some other topics related to uh, their properties, their usage, and some implementations combined with arrays, pointers, and functions. So let's start. First of all, a structure is a composite data type. It is a user-defined data type, derived data type, and what it basically does is to bundle several uh, primitive data types in one single variable. So basically what we do is to use the keyword struct, then we uh, give it a name, a valid name, and then within curly braces we describe the body of the struct variable. Okay, so in this case, for instance, to illustrate more clearly, we created an unstructured variable named student because we want to store in one single variable several data that refer to the same student. So for this purpose was the name, which is an array of characters, the age as an integer, and the ID as an integer also. So as you can see, it's one, to say somehow, it's one logical unit of information, but it has several data that we want to associate with this variable. Okay, so uh, in these curly braces we place all of the member data of that structure variable. Okay, this is how they are called, member structure members. Okay, the data inside this structure. Okay, to create a structure, we will have the following the following steps. So we first use the keyword struct, then the valid name, then within curly braces all of the member variables that we need for that structure, and then we create an instance of that struct data type. So here I'm defining also struct student, which is I'm creating an structure of type student that has these three member variables, and it's going to be called st. So in the beginning, when I write mm, this specification of the struct, I am not creating this variable in memory. I am just uh, mm, writing some information for the compiler to recognize later on, whenever I define the actual variable, uh, what I mean actually. So for instance, I'm here defining a struct student st, and this is the actual creation in memory, allocation in memory of that structure. Okay, but here I'm just somehow telling the compiler what does that struct student mean. Okay, what does that mean whenever I create it, to avoid any confusion or error of not declared data type. I can create it in this way. First of all, specify the member structure members, and then create the actual variable, or I can create it right here at the end of this in this curly bracket, and after the closing curly bracket, and before this semicolon, I can place the name here if I want it, or separately, wherever I want. Okay, so it's just like doing here. I have the int data type, but whenever I associate a name to that data type, I'm actually creating in memory that variable of type integer in this case. So what's going to happen whenever I create the actual variable here, uh, this space in memory will be allocated and in an adjacent memory addresses, and we will have 20 bytes for this character, for this array of characters name, and then next are going to follow an integer age and an integer ID. Whenever I want to access every individual structure member, I will have to use the name that I gave to this structure variable, and then place the access operator, which is a dot, and then the name of the member variable. So if I want to access the name, I will have to use the expression st dot name. This is the access operator. Okay, so I refer to all of these member variables, but the name of the structure followed by a dot. Okay, and then the name of the um, structure member. Okay, so let's start with an example in our compiler, online compiler. All right, let's start with the example. First of all, let's create the structure. So struct student, and then this curly brackets, and at the end semicolon. Okay, so the member of the structure are going to be these three. The name, age, and ID. We already know that. Now I'm going to create the actual instance of that structure student. Okay, so remember, I will have to use the keyword struct, then student, which is the type of struct that defines that it has these three member variables, and then the name. So I'm going to use st. All right, it's created. Let's see if I have any errors. No, I don't. However, it's not doing anything yet. Okay, so now let's access the members. Okay, so from now on, I will have to refer to this variable as just simply st. So st dot, and let's access the name, and I'm going to assign the name of, let's say, for instance, John Smith. However, first of all, you remember that we'll have to use a function which is defined in a string.h header file, because we cannot assign the member just simply like this, John Smith, and expect this to work. It will fail because it is an array of characters, so we'll have to pass character by character, one by one. So for that purpose, we will use this strcpy function, which actually copies a string into an array of characters. And this is the syntax. First of all, we include a string.h header file, then we specify, first of all, the destination where we are going to write that string of characters, which is in this case st.name. This array inside st, which is a variable of type struct student, and then the string itself, just like in here, and end by semicolon. Okay, next st age. In this case, we can access it directly because it's just one single position in memory, not an array. And the age is going to be 20 years old. Then st dot id, and let's say the id is this one, simply. Okay, now we're going to print the result. the newly changed, the newly assigned values. So let's say here name, and we need a string. So this is the format specifier, and name, which is the parameter that has that string. Okay, name printf. Now let's change the format specifier. The next one is a integer. The following is also an integer. So okay, and now here it's st.h, st.id. Okay, let's hit run, and here we have, oh, I forgot to change this here. This will be h, and here the id. Okay, we're ready. This is okay. So remember, the access specifier is the name of your structure variable, and then the dot operator, access operator, and then the member, the structure member that you want to access. Okay. All right, let's do the same assignment of values to all of these uh, member variables of the structure, but this time we are going to use the initializers in curly braces. What I mean by that is we are not going to access uh, every member at a time, but we're actually using the following technique. Sorry, I'm going to comment this part of the program. Okay, and now I'm going to assign the values for the struct all at once. So the first one is the string, or for an array of characters. So I'm going to copy here this one. Remember, when we write text or a string, we'll have to begin and end with a double quotation marks, then comma, separator, and then int h, that was 21, I guess, then comma, and the following is the id. So as you can see, I am initializing everything by these curly brackets, and specifying in the same order all of the values that I want to place in this struct student st. Okay, so let's run it. As you can see, it results in the same, we have the same result. So this is another way to do it. If you have any error with this, it's because maybe the version or the standard that supports of C language is new, because I don't know, I remember that it's maybe implemented after the first standard, C89, it may be. So beware if it doesn't work in your compiler. Why I'm missing now? Struct with our struct. Okay, now I'm going to create another struct of the same type, another struct variable student, but this time I'm going to call it st2. Okay, so pay attention to what I'm doing now. Now I'm going to print the values inside st2. Okay, so I'm going to change here in printf st2 dot name dot age dot id. Okay, and now let's hit run. It's some garbage values, but now I'm going to do the following. Remember that that I already initialized this st with these values, right? So if I have st with this values inside it, what will happen if I do the following? I am initializing or assigning the values within st to st2. And now I'm going to run the compiler. As you can see, it now copied the values assigned to the st. So I'm doing basically like a copy of st in st2. Okay, this is another way of initializing a structure. You passed the values of an already created structure to the older structure. Okay. Okay, now we'll talk about something known as structure padding in when working with structures. Uh, if you remember, we have talked in previous videos about the size in bytes of different data types. So for character, the data size is 1 byte, and for integer variables, the data size is 4 bytes. So you may expect that the entire size of this structure to be 6 bytes, because we have here 4, then 1 byte, and another 1 byte. We will have a total of 6 bytes. So you may expect in memory, from the point of view of a 32-bit processor that is able to take 4 bytes of code at a time, at once, in a single CPU cycle, to read this 4 bytes, and accordingly, according to the size of our struct, we'll have the four. Actually, sorry, the characters arranged in this way: 1 byte, and the integer age that occupies 4 bytes will be in the following 4 bytes. Okay. So for that, so in this case, what would happen when the processor is reading memory is the following. It can read just 4 bytes at a time. So in the first cycle, it will read character C and D, but for the integer age, will be able to read just half of this integer age. As you can see, just the first 2 bytes of the 4 bytes. Okay. So you will have to read in a single cycle the other remaining half of this integer age. So this somehow slows down the speed of your program. So basically, by default, the compiler arranges data in such a way that data types can be read in just one single cycle. So what it will do in the real life is actually um, organize the data as follows. It will have character C and D here, then it will leave a space, and it will place the entire integer age in just one single area of memory of 4 bytes. So in this case, we will do one reading for C and D. It requires just one reading for reading the character variables, and then it does one single reading of the 4 bytes for integer age. So it has an overall improvement of the speed for reading variables. Okay, so it results in a wastage of memory, but it leverages execution speed. So we will see in a program, an example program, how to alter this arrangement in memory for you to know. Okay. Okay, now let's review the form one of the latest programs that we made. And as you can see here, we have 20 bytes, sorry, plus 8 bytes, because it's 4 and 4 bytes. We'll have a a total amount of 28 bytes, just like it says here, okay? But let's suppose that I add to this struct student a character variable, C, and as you can see, it is just 1 byte, okay, just one additional byte. So you may expect it to be 28 bytes, okay? Because at the end I am using the size of operator for struct student, and we will see. We're expecting 28 to be the size in bytes, okay? But it will be actually 32. And it's just the structure pattern that I talked to you about previously. So what we are going to do basically is, okay, first of all, this structure padding improves execution speed, okay? But we can force the compiler to avoid doing this structure padding, and it will actually squeeze all of the variables in memory, so it will not waste any space. So how do we get the compiler to do that? We can use the preprocessor directive number sign pragma and pack. Okay, pack 1. Okay, now let's hit run, and as you can see now it's forced the um, arrangement in memory to just allocate the necessary space and not leaving any um, padding effects in our structure. Okay, so you can use that, or here in the structure, whenever you um, specify your structure here, you can use this uh, attribute, and then packed, and then you end with this double underscore in the beginning and the end, and then packed within parentheses, and hit run, and we will have also 29. Okay, if you leave it normally, you will have the structure padding as expected. Okay, alright, let's now review the concept of pointer to structure. Here we have already the same structure student, and we are going to create a pointer to that type of a structure. For that purpose, we will use struct student to specify the data type that we are pointing to, then the pointing operator or pointer operator, and then the name for that pointer. So we have here st, which is a pointer to a struct of type student. Okay, we already created an instance of that struct student and named it John. Now we initialized the st pointer with the address of the actual structure, okay, which is John. From now on, we can access the structure members of John with that pointer, okay. So we will have to be aware of how to access these structure members now that we are pointing by a pointer, not the actual direct access of structure John. So as you can see here, we have the address of John stored in a pointer st. So for accessing every structure member, we'll have to use this operator, which is a hyphen and an arrow pointing to the right. So this is the address. This is the access operator whenever we are using not the actual structure but a pointer to that structure. Okay, so as you remember, here we use that simple dot operator whenever we are working with the um, with the actual structure. Okay, because the actual structure was here named st previously, so we use dot operator to access name or wherever uh, member of the structure. But whenever we're using a pointer to the structure, we will have to use this arrow, okay, operator, because it basically dereferences that um, the address of that structure. And you can also use this notation, which is within parentheses, you first dereference the st, which is a pointer. If you dereference it, you will be well, actually, you will be accessing the structure directly. Okay, so you can use both of them, but remember, I don't know, this is more silly, I guess. So it's your choice. Remember that how you access whenever you are pointing with that pointer to a structure for accessing the member variables. Alright, now I'm going to create a pointer to structure, and I'm going to access these values to be printed by that structure. So remember, we use the keywords struct, then student, which is the type of struct, and then pointer sign, and let's say pt. Okay, now I'm going to initialize that pointer pt, pointer to structure student, with the address of st. Okay, as you remember, we already initialized st to these values. Okay, now pt has this address, and I'm going to use pt. Remember the arrow operator, because we are now not using the st, we are going to replace st by pt. And so this simple dot operator for access will not work. Okay, so remember, we are going to use the arrow operator for accessing via a pointer, okay, of that to that structure. As you can see, it works normally. If I just leave it with the access operator as the pointer, it will throw an error, because now I'm using pt, not the actual st. Okay, however, remember that I can do the following: within parentheses, the reference the pointer pt, that will be same as writing here st and dot id. In this case, it will work again. Okay, however, we can do in any of these two notation styles. However, I don't know, I like this one more straightforward, because it's easy to remember that it's a pointer to the particular structure. Okay, now let's review a facility of C language to replace the names of primitive data types for alias, user-defined alias. And this is by using the typedef keyword. So here is a simple example. Here we use typedef int keyword, and then num, and we finish with semicolon. In this statement, I'm basically replacing int by the alias num. Okay, so we are not creating any new data type, but we are actually telling the compiler that whenever the word num appears in our code, it will mean int. Okay, so as you can see here, num age is equivalent to int age. So in this case, it is not particularly useful, but as you can see here in the previous examples, when creating um, structure variables, we have to use this long statement of a struct, a student, and then the names that we use for that particular variable. Uh, so we can change this long name for a shorter one by using this property of typedef. So for instance, here we are going to do that precisely. So we use typedef, then struct student, just like before, but now we are including here a name within this the end of this struct specification, and it will result in the replacement of struct student by this word student. So now I won't have to use again struct student, but from now on I will use just student st, and it will be equivalent to struct student. Okay, so it is shorter by using typedef. Remember, you write here the alias that you want to replace this long struct student data type. Okay, also you can do that in the following way. You can omit completely this the name of your struct type, so it is like an anonymous struct, but remember that the mandatory thing here is to use the alias name here at the end of your struct, and then you are ready to define or create your struct variables simply just like this. Okay, let's see an example. All right, let's just simply use this typedef here, typedef keyword, and then struct student will be replaced by, let's say, stu. Okay, just stu. So I won't have to use this struct student, but just as stust. Okay, and now let's run, and we have the same result, just that we didn't have to write all the struct student large name. Okay, just stu that was placed in this part of the struct. Okay, as an alias. Okay, thanks. Okay, now in this example we're going to use something known as nested structure. Well, it turns out that we can place a structure inside a structure. Let's say, for instance, we already have the struct type student. Okay, well, let's say now that we need a struct called team, because there are teams of students for studying and playing sports or whatever. Okay, so this struct team will contain struct student st1. Okay, then let's say, for instance, that just 3 students. Okay, so as you can see, a student is a structure that stores a name, the age, and an ID. Okay, and this team stores the structures of 3 students. Okay, I forgot to uh, name it name them differently, all of these struct variables. Okay, so remember what we learned previously. I can initialize every struct just like in here, initializers. So, first of all, remember, I will have to create an instance of the struct. Remember that this lines here are not creating any structure in memory, any structure variable. So it's up to me to create them. So I will start by creating, say, for instance, here a struct of type team, and the name is going to be I don't know, group. Okay, I already created. So if I wanted, I could initialize this structure. Remember that inside it will have inside this structure I mean, the difference between this structure that we created here in the previous program and this one is that this one has three structs inside it. Okay, so I will have to use this comma separators, and now I can try to initialize this way. Okay, so I'm going to copy the same name, the same values. Remember, it starts with the name. Okay, I'm going to comment here this one, and let's see if it throws any error. It says team group. Okay, so what do I do now? Okay, now the name doesn't exist here. So how will we print these results? So I will have to access every structure, inner structure. So for that purpose, I'll use team. Remember that the members of the structure are accessed by this dot operator. Let's erase the previous ones. So whenever I type team, capital letters, oh sorry, no, it's actually group. I must refer by the name of the struct type team, which is group. Then access operator dot, and then what else? Remember that this one is going to be considered student st1, so it will be group dot st1, and in st1 I will have to access again the name, so I will have to again, it's like multi-level access or something. So as you can see here, I'm first using the structure name, which is group, for a team structure, and then accessing to the st component, st1, sorry, which is the first student, which is this one. Okay, or else then I will access the name inside this nested structure. So I will copy and paste here, and I will change name for age and then ID. But let's change it. Let's say 28 and 1555 to check I'm doing okay. Smithson. Let's say it's Smithson. Johnny Smithson. To change a bit. Let's run it. Okay, it is okay. So as you can see, I'm doing access to the inner access and inner data member, structure member variable. Okay, now remember that I could have done the following. First, creating a here, okay, on struct of type student, and then initializing that just like in here. Let's see if I can copy. Sorry, in this way. Okay. Now let's say here Sarah Rogers, whatever age and ID that I want. Okay, and now that I have a struct of type student, I can assign. Oh, sorry, I missed the name. So let's say, I don't know, STU, whatever. Okay, so this is the name, and now I can replace this one here with just simply dot because I am the team group. The dot is for accessing the any of this, in this case st2. So st2 equal to stu. So what I'm doing here, since I am already inside the team, which is group, okay, I could have say here group dot st. So I'm actually accessing this nested structure, and I am initializing with the already created value of stu, which already contains Sarah Rogers, blah blah blah. So I'm placing basically those values inside this stu, uh, which is the same type as struct student. I'm placing assign them to this uh, inner structure. So let's see if I have any errors. Oh, for that purpose, I will have to copy this. And now I will have to change this to st2, which is this one, and see if I have all this data here, which is the Sarah Rogers 25 and so on and so forth. So let's see. I guess I did it right. Okay. As you can see, I guess I can also omit this group and just leave the access operator because I am already inside uh, group. Okay, so I don't need to specify that I am already accessing group. Let's see. Okay, doesn't show an error. So that's it for nested structures. Remember that I could have choose to do in the more tedious way by specifying group, which is the team that contains the three structures, then access operator, then uh, st1, and then st1 name, and then initialize it to some value, and then repeat it for the rest name. So the next one is age, the next one is id, and so on and so forth for the rest st2 and st3. But it is simpler like in these initializers here in braces. Okay. The following examples will illustrate how to return more than one value, that is, several variables, from a function, and how to receive several arguments. And this is by using an structure. Remember that you can pack several variables into a single structure. So this is basically how we will get to do that from functions. Okay. All right. Our particular example here is the following implementation. We create a structure named set, and it contains three integers. Okay. Also, we create a function that will return a structure of type set that is with three integers, and that it will take as argument one integer. Okay, and it will return three integers via this structure set. So first of all, it creates an struct set, uh, an structure of type set here with three integers, and its name result, and it will take the value of a, and the three integers will be the result of raising that value of a to the power of 2, power of 3, and power of 4. Okay, so these results are going to be stored in that set structure, and that set structure is going to be returned. Okay, then whenever it is returned here, just like in here, that it's next power and the value is 3, so 3 is the value that's going to be raised to this consecutive powers, will be collected here in this previously created struct set, and the result will be displayed here. Okay, so as you can see here, we create here a struct set one of this type with 3 integers, and then we call the function next power of 3, and we pass that this argument. So this will calculate the power of the second power of 3, the third power of 3, and the fourth power of 3, and then it will retrieve the result back into this structure. Okay, and it will be printed here. It could be whatever calculations that you need or processes, but the important thing here is that we are going to return all of these results in just one single structure. Okay, and as you can see here, value here is 3, but let's change it now to 2, and let's hit run. So uh, 2 raised to the second power is 4, then to the third power is 3, and to the fourth power is 16. Okay, it's working all right. uh, just bear in mind that we didn't use the call by reference. That is, we didn't pass any address of the actual structure set 1. However, there is a way to do that. We can have used this example here, in which the next power, the nth power of a, actually takes the value of integer a and also takes the structure, a reference to a structure. Okay, so this is called by reference. In case that, say for instance, that we created this one, a structure set 1, and that we wanted to change the actual existing values inside. Okay, so we will use the call by reference. Remember that we learned that from in the video functions. Okay, so that's it for now. All right, now let's review this topic of array of structures. Um, we can also, as you can see, an structure can contain arrays, but also you can pass structures to functions and return them from functions. But you can also create arrays of structs. As you can see, you can mix several implementations of these C programming language elements. So what's the idea behind this? We will use the same notation. Remember that there is a name for the array and the total number of elements that it will hold. And first of all, preceding the name of the array is the type or the data type that it contains. Remember that it can contain only elements of the same type. So in this case, it will all of the elements are going to be structures of type student. Okay, and the name of the array is st, that contains 3 elements. So basically it will create space in memory for holding this structure of a student that has this car name of 20 bytes and then 2 integers. Okay, so it will look like this in memory. So it has 3 units, 3 elements of that type. Each of them has a base address. I mean, it starts from this address, and the rest of the addresses are contiguous, adjacent. And basically, what the array will contain is the address of the structure, because it will be like too much in this first position to have all of this data. So basically, it has the base address instead. Okay. How do we operate upon this array of structures? Okay, remember that for a simple structure we used the dot access operator. Okay, so remember that for an array, we will use the index operator. Okay, so first of all, we have to access first the uh, element, that is, what structure are we working on. So let's say, for instance, that okay, that I want to access the structure 1, which is the second, okay, by the order of indexes. So I will have to use st1. I am already here in this structure, and for accessing any particular structure member, I will have to add a trailing dot access operator. So it is st square brackets 1, that is accessing this element here in this array, and then dot operator, and then the element that I want to access in this case is h. So I'm writing as this element as st1, and I'm writing the h. Okay, so it is following by the dot operator because I already accessed the structure. Okay, so first, in this first step, I'm accessing the element, that is that particular position in the array. Then once I am here, I already accessed the structure. So next is accessing the wherever member that I want. So for that purpose, I use this point, and then I can do whatever I want. For instance, here I'm assigning the value of 55, 56, sorry. Okay, now let's say that I want to change the name. So remember that I cannot do that directly in a single assignment, but I will have to use the string copy function, and the string copy will receive the destination where I'm going to place the name, which is a string. So in this case, I will write Bridget Nelson, and I'm going to write it where? Well, obviously in the name member function. Okay, so remember, I will use the same um, procedure st, then the index, that is in this case the second structure in this position, and then dot operator, and then the member variable, in this case name, which is the destiny. Okay, so this is how we do that. And now let's change the id. So remember, I will have to use st uh, index 1, then dot operator, then id. Okay, so it goes like this: st index 1 dot operator, then id, and then wherever number for the id. Okay, okay, now I'm going to create an array that contains structures of this type st1, which is a student basically. So remember that in this particular moment, I haven't created the unstruct of the type st1. Just I'm specifying that whenever I mention here struct st1 is because I'm going to create one. Okay. So let's say uh, I don't know, d. Okay. So now compiler will recognize that this d is a struct st1, which is all of this bunch of variables. Okay, so as I said, I'm going to create an array. So here's the name. The array is named d, and it contains structures of type st1. Okay, um, so what can I do now? I guess I can also initialize it just like I did before. So let's try an example. The first is an integer, so I will have to use age. So let's say 18. Then sorry, I will have to use this because they are like nested. Okay, so this is one structure, then the next one, and the next one. Okay, so uh, double average, let's say 4.8, and name, let's say Alex Thompson, I don't know, and then let's copy this one, and let's say John Thompson, and let's say different age, and then the next one, so let's leave it 28, I don't know, and 0.5, and I don't know what it is, maybe Robert. Okay, now let's see if it throws any error. And we are going to access one particular element. So let's say, for instance, this is D, so we're going to access some of the ages. Which one? Let's say that the first. So remember, we will have to use first D. Let's erase this one. D. This is the index 0, then dot, because we are accessing now a member of the structure in this position 0, and is H. Okay, then we are going to print one name, and the name is going to be we also need this structure that it's an index, so let's print the third one in the location 2, and the member is the name. Okay, and we'll see, let's print the this is a double, so we will need lf format specifier, and we are going to print average. So we're going to print the average of this Robert Thompson and his name Robert Thompson, and the age of the first here, which is 18. So it should show 18 Robert Thompson and an average 4.5. Okay, we are right. This was just a review of the access in array of structures.